Today in class 12th, I am telling you about the principle and working of the potentiometer. Before this, I have told you about the potentiometer, about its construction and the properties of the potentiometer wire, and that why this is it is superior to the voltmeter, and this is an ideal voltmeter when the current is not taken from the cell. So today I will take the principle and working of the potentiometer. So first I take the principle of potentiometer. Principle. Now this is the potentiometer wire. Rheostat key K. This is E naught. Here I take now the current is like this, AB. I told you that the length of the potentiometer wire is 10 meter, and this 10 meter wire is mounted on a rectangular wooden board in the pieces of 1 meter each. So there are 10 pieces, and then the ends of the wires are connected by means of a metallic strip which are of equal width and of the same material, so that the resistance of this strip may be negligible in comparison to the resistance of the potentiometer wire. So here in this figure I have shown you that AB is the potentiometer wire, and that I have shown you the battery whose EMF is E naught, the key K and rheostat. This is the main circuit. The auxiliary circuit is that having a primary cell and a galvanometer and then a jockey. So this is the primary circuit. This is the main circuit. Main circuit. This is auxiliary circuit. Auxiliary circuit. And I also told you that whatever changes are made in the circuit, that is only in the auxiliary circuit. The main circuit remains always the same. The current from main circuit is passed through potentiometer wire AB. There is potential drop along the length of वायर ए। तो क्या जैसे ही हम इसमें करंट फ्लो फ्लो करते हैं तो वायर ए में पोटेंशियल ड्रॉप होता है. It means that the potential at point A is maximum and that the potential at point B is minimum. So there is a potential drop across the along the length of the wire. The potential drop is proportional to the length of wire. तो जैसे वायर की लेंथ बढ़ती जाती है वैसे पोटेंशियल ड्रॉप भी क्या होता है, बढ़ता जाता है. So it means that this V is proportional to L. So what we have? If we draw a curve, this we take 0, this is now length along this x-axis, and this is now your y-axis. Here we take the potential drop. Along this y-axis. Then what we have? This is a straight line. That V is proportional to L. This is V proportional to L. So larger the length, larger the potential drop. So as we go from point A to the point B on the wire, the potential drop increases. So now here V proportional to L, and this can be written as or V equal to XL or X equal to V upon L, where X equal to potential gradient X, that you call the potential gradient. I have told you about the gradient earlier also when I taught you about the electric field and the electric potential, that the negative gradient of the electric potential is equal to the electric field. So this is also what the gradient, that is the potential is changing with the length of the wire. So I told you that whenever there is a change of a physical quantity with the space, then there is the potential gradient. So here this V changes with the length of the wire. So this is the potential gradient, X equal to V upon L. So this X, you can have the unit of this one. This is now volt per meter. And this is what the electric intensity or the electric field at this one. So we also measure it in Newton per coulomb. This is another unit of this potential gradient. So how we define? The potential drop per unit length of potentiometer Y is called potential gradient. Potential drop per unit length of the potentiometer wire is called the potential drop. So this is the principle. And now I will tell you the working of this one, that how does it work. How can this can be used in case of this potentiometer. So now I take the working of this potentiometer. Now the working what we have the same circuit diagram. RH, this we take. Now K, positive, negative. This is now E naught. This I take. This is the galvanometer. This is galvanometer. That I show you here, and this is also shown to this here, and this is shown to this one. This is now suppose A, and this is now B. This is suppose A1, this is A2, this is now N. So now I say that this is the galvanometer. Let the EMF of this cell is E. Now this provides a current in this wire that flows like this one, and this also provides the current. So the positive terminal of this battery and that of the primary cell are in the same point. So let E naught equal to EMF of battery in main circuit, and E equal to EMF of primary cell in auxiliary circuit. Auxiliary circuit. We will use this principle of potentiometer. This is not joking. Let the current from main circuit is passed through potentiometer by AB. Now let the jockey J is at point A1 of by A1, and the potential drop at A1 is equal to V. Let me take it to be now V, or this is now suppose we take it to be now this B1. The V1 is less than what? The E. The EMF of this cell. This potential difference is less than the EMF of this cell. So the current will flow in this circuit. So direction of current. This is equal to what? A1, G, E and A. G, E and A. So current will be like this. In this way. So this is what? The clockwise. So deflection in the galvanometer, that will be towards the left. The deflection in galvanometer is towards left. So it means that this will be in this way. This I see in this direction. And now again, let jockey is at point A2 of wire AB. Now the length has increased, so the potential drop has been increased. The potential drop at A2, this is equal to B2. And now what is? Now V2 is greater than E. The EMF of this cell, V2 is greater than EMF of this cell. It means what? That the current will pass like this way. The direction of current. This is equal to what? This is now your A, E, G, A2 and A. So now current will be in this way. This is now direction of current. This is now direction of. This is now your what? The anti-clockwise. anti-clockwise. So deflection in galvanometer. Deflection in galvanometer is towards right. Towards right. Towards right means the deflection will be in this direction. Towards right. So now between points A and A2, at point A1 the deflection is towards the left and at A2 the deflection is towards the right. It means that there will be a point between A1 and A2 where the deflection will be 0. Let जो कि J is at point N of wire AB, and at this point the potential drop at AN, this is equal to, suppose, V naught. This is not V. Then what we have taken? Is equal to V, the potential drop. V is equal to E. It means that no current in galvanometer, so it shows no deflection. Deflection in galvanometer is equal to 0. When deflection is equal to 0, it means that the cell is in open circuit. It shows that primary cell is in open circuit. So no current is taken by the potentiometer from this cell. It is the valence position of potentiometer. It is valence position of potentiometer. It is the valence position of potentiometer called no deflection. in galvanometer. So what does it show? That when the current is not taken, this I told you earlier, and when just I started the potentiometer, that potentiometer is based on null deflection or no deflection method. So this is what the no deflection method. So no deflection method means that no current is taken from the primary cell in the auxiliary circuit. So the cell is in open circuit. At this time, this potentiometer behaves like a ideal voltmeter. In this situation, the potentiometer is an ideal voltmeter of infinite resistance. So this is what that potentiometer is more better than this the voltmeter. So this is about the working of the. So we have now 3 points. At the point A, the potential drop is less than the EMF, and at the point A2, the potential drop is more than the EMF of the cell. Then between A1 and A2, there will be a such point where the potential drop is equal to the EMF of the cell. At that point, no current will be taken from the primary cell in the auxiliary circuit. So auxiliary circuit is an open circuit, and that the resistance of the potentiometer wire, that is AN, that will be equal to infinity. So this will behave like an ideal voltmeter of infinite resistance. So this is what the principle and the working of the potentiometer. Thank you.